Good? Very good?
Yeah.
Okay, so in this experiment, we simulate the existence of a disturbance force on a working cylinder. So this right here is a combo. It has two, as you can see, this is the left hand side hydraulic cylinder, and that one's the right hand side hydraulic cylinder over there. And this one is a working cylinder, and this cylinder mimics the existence of disturbance. So this cylinder wants to occupy a certain position here, in this case 140 millimeters, and this load cylinder is going to interfere with the position, with the location of the working cylinder. But the working cylinder is going to be controlled by a controller, and so the working cylinder is going to overcome the force exerted on it by the load cylinder and occupy its position, the position given by the voltage that is applied on this valve. Okay, so I'll tell you in a minute as to what this valve is. So let's go through all the components that we have here. So we have the usual power pack, and we have the usual arrangement here of hydraulic distributors and the pressure relief valve to control the pressure. So this experiment requires 50 bar of pressure, which is incidentally the pressure developed by the pump. So this right here is the pressure reducing valve, and this right here is a direction control valve, which is spring centered. Okay, so this only has one solenoid here. This in the middle is a special valve. This is a proportional direction control valve, and this particular model is controlled by voltage from 0 to 10 volts. So what that means is the spool of this valve can completely open, completely close, and partially open, partially close, depending on the voltage that is applied to the solenoid of this valve. And it's got some cables coming out of this. There is also a 7-pin connector for data acquisition of that valve. So just bear with me. Let me turn this on, and I need to flip a lot of push buttons and switches. So just bear with me as I demonstrate this experiment to you. So as you can see, this pressure has been set to 50 bar, and I am going to advance the load cylinder and then reduce the pressure behind the load cylinder. So I'm going to reduce the pressure that is supporting the load cylinder. Okay, so let me do that in a minute. So as you can see, the load cylinder has advanced. It has occupied some position here. That's not relevant. So what we want to do now is we want to reduce the pressure on the cap side of the load cylinder, and I'm going to manually do that. So I'm going to reduce the pressure to about 30 bar, because even the working cylinder is being pushed at 50 bar. So we want to reduce that pressure, which is lower than 50 bar. I'm going to just keep it at a value, this value right here, which is 30 bar. And I want to put this whole thing, this DCV in a closed loop configuration. So I'm going to flip a switch in the back there. And it's in closed loop. And now if I press this push button, you can see the working cylinder move. So that takes it to 10 millimeters. Now this has to travel all the way to 140 millimeters. So I'm going to push the other switch, and you can see that the load cylinder is kind of interfering its progress. It can't reach 140 without pushing the load cylinder back. So that's what the working cylinder is going to do now. And one more time.